Previously, we learned that if the base was not written for the logarithm, you were to assume that the base was 10. That was called a common logarithm. We have another special base, and that is called having a base of e. That's a natural logarithm. Instead of writing log base e, what we typically write is ln, which is natural log, but the letters are backwards. Don't know why. Log of the natural variety. It's on your calculator. So go ahead and find that on your calculator. And common sense wise, this is going to be great. The inverse of natural log is anti-natural log. Natural log is on the left, about 2 buttons up above the on button. ln, it's natural log. So example A, use a calculator to find the value to the nearest 10,000th. All you have to do is type that into your calculator. Should get 2.2322. Anybody not get that? The second one, anti-natural log, it's on the same button. It's e to the exponent is all that means. I'm just going to write that down here for your notes purposes. You would not have to do this on your homework, a test, or a quiz. You should get about 2.1882. For 3 and 4, 0.0208 and negative 1.5606. Questions? Pretty simple. Example B. Solve each equation. Round solutions to the nearest hundredth. Yesterday we learned that since we had the change of base rule, in most cases we would want to have a base of 10. But since we also can use our calculator that has a base of e, you can use it with a base of e as well. Depending on the problem, would determine which base you would want to have, either a 10 or an e. For this first problem, if you natural log both sides, natural log of 9 equals natural log of e to the x. If you recall one of the properties that we learned from logarithms, if the base, in this case the base is e, is the same as the base of your argument, then this whole thing on the right simplifies to just the exponent. So it's just x. So we have natural log of 9 equals x. That's the exact answer. Directions say round it to the nearest hundredth. If you put that into your calculator, you get 2.20 to the nearest hundredth. Number 2, if you do the same thing, if you apply natural log to both sides. The reason we're choosing natural log is because on the right side it has a base of e. Because the person who decided to call it natural log decided to use the symbol ln. Perhaps it was an alcoholic. I don't know. I'm guessing they wanted to start with an L just like a log does. Log al naturel. It's French. So the right side just becomes 3x. Then you get x by itself, divide both sides by 3. You're going to get natural log of 18 and divided by 3 equals x. That's the exact answer. It's as simple as you can get it. If you put that into your calculator, you will get approximately 0.96. And I encourage you to check in your calculator to make sure you know how to use your calculator correctly. You need to close your parentheses after the 18. Questions? Would someone like to wager a guess on what you think you should do for number 3? What is the same thing? Please keep in mind that each of the problems we've done so far, there's been one term on each side. If there's more than one term, you can't just natural log each side. You want to get it so there's one term on each side. What does the left side become? 6x. And then how do you get x by itself? Divide by 6. Put that in your handy dandy. That's approximately 0.70. Number 4, if you notice, there's already a natural log there, and if you look on the right side, there's a natural log and the base is e. So this whole right side just simplifies to the exponent of 0.5t. So the left side stays the same. To get t by itself, divide both sides by 0.5 or multiply both sides by 2. That's what I'm going to do because I don't like divide by a decimal. It's the same thing though. That's the exact answer. Your approximate answer, 6.07.